Okay, thank you. So it's a great pleasure to announce the organization of this next edition of the competition. The competition has already been mentioned a few times during the day, so I guess that most of you already have heard of it, but just in case, a really short introduction of what is ICCMA in general. So I start with a sentence that I took on the official website of the competition. So I'm not sure exactly who wrote this sentence first, but I think it perfectly sums up the spirit of what we try to do. So the competition aims at nurturing research and development of implementations for computational models of argumentation. And in the last years, it has allowed to compare and classify the different methods for solving classical reasoning problems in abstract argumentation. So as you can see, we are now at the fourth competition. On the 3 previous editions, we have in total 43 solvers that were submitted. So some of them, of course, count for 2 or 3 because they were submitted to different editions of the competition. But we believe that it's a really important thing for the community to have this effort for implementing algorithm and providing source code in order to reuse this algorithm. So we hope that the next edition of the competition will have a similar success and will give new insights on algorithmic issues for formal argumentation. I will briefly introduce the background notions related to what will happen at the next competition. As you can see here, we will of course talk about classical Dung AFs, but also about ABA, assumption-based argumentation. And then I will introduce the rules of the next competition and some concluding remarks. So of course, we start with a very well-known classical abstract argumentation. We will focus on a slightly different set of semantics compared to what was the case on the previous editions. Because as you can see, so I introduce, of course, conflictfulness and admissibility just as preliminary notions for the other semantics. But then we focus on this set of semantics: stable, complete, preferred, semi-stable, stage, and ideal. So we chose to remove the grounded semantics because we believe that it's not really challenging, because we all know a really simple linear algorithm for computing the grounded extension. So it did not seem to really fit in something like a solver competition. But otherwise, we keep the same set of well-known also semantics. So the 3 ones here introduced by Dungs, and also the famous semi-stable, stage, and ideals that were also really studied more recently. So then for the first time, we will introduce structured argumentation to the competition. We chose assumption-based argumentation. You could ask why ABA instead of ASPIC+, the diffeasible logic programming, or other existing logical argumentation frameworks. To be honest, at some point, it's just because we had to choose. All these frameworks, I believe, have really strong qualities and can be applied in many interesting scenarios. So we had to choose. Maybe we were oriented by the fact that we may be more familiar with this framework. So we'll give the choice to the future organizers, maybe to change the framework if they think that it's a good idea. But for now, it will be ABA, assumption-based argumentation. So we have, for a framework now, a logical language, a set of symbols to build arguments from, and a set of rules. So here's x0 until xn are elements of the language. And a special subset of the language is what we call assumptions. So these are the elements of the language that can be used in order to build arguments in ABA. And finally, this function represents contrariness from assumption to any element of the language. So on an example, it might be clearer for people who are not really familiar with this framework. We have here this language with ABCs that will be our assumptions. And as we can see here. So PQRC or other elements of the language. Our rules are represented like this. So if Q and A are true, we can deduce P. Here, this is exactly as if we had a tautology. So Q is considered as a fact, and so on. To construct arguments from an ABA framework, we use some classical mechanism to chain the rules from the framework. So here, for instance, with the rule BC implies R, we can construct this argument. So if we have the assumption B and C, we can deduce R. This is an argument for supporting R. And here with two rules, the fact Q and the rule P is implied by Q and A, we see that only the assumption A is required to support P, because the other literals that appear are deduced by rules. Q is not an assumption, it's a fact, and here it's the conclusion of a special rule. And then to construct the attack relation, very simply, we say that an argument attacked another one if there is a notion of contrariness between the conclusion of an argument. So here, for instance, here is the conclusion of arg1, and it is the contrary of an assumption which is implied in the building of the other argument. So since R is the contrary of A, we say that arg1 attacks arg2. So this is it for the background notions about ABA. Before closing this part, we define here extensions not in terms of arguments, but in terms of assumptions. Actually, both ways can be used. Here we chose to focus on this way to define extensions. So here we will define an extension as a set of assumptions, such that a set of assumption A1 attacks another set of assumptions A2 if an argument supported by the first set attacks an argument supported by the second set. And then the notion of defense can also be adapted to sets of assumptions. And when we have the notions of attacks and defense, then we can define conflict freeness, admissibility, and so on. So this time, this is it for the background notions. Regarding the competition, we will, of course, keep the same tracks that were introduced on the previous competition. So what I call here main track will be static reasoning with abstract argumentation frameworks. In the dynamic track, we'll have evolving AFs. So an AF can be updated with new arguments, new attacks, and so on, or removing arguments or attacks. And of course, a sub-track about structured argumentation. For each track, we will define a subtrack for each semantics. And each subtrack is made of several reasoning tasks. So I will now give a bit more details about that. Regarding static argumentation frameworks, so as I said previously, we have the same set of semantics as previously, except the grounded semantics. But the other new thing here is that we chose to remove the EE problem of enumerating extensions, but chose instead to count the extensions. So this is what we call the CE problem, and the other problems are the same ones, meaning SE for give some extension, and DC and DS respectively for credulous and skeptical acceptance. So for each subtrack, we will have 4 problems, these ones, except of course for the ideal semantics, because there is always one extension under the ideal semantics. So of course, CE is trivial. And also since there is only one extension, DC and DS coincide. So we will only run one of these problems. So this is it for the main track, the static abstract argumentation. And as I said, the real new thing will be the CE problem. Regarding the dynamic track, we chose to focus for the moment only on the Doom's classical semantics, so complete, preferred, and stable here. And of course, with the same 4 problems as I said just previously for the main track. But the new thing that we want to introduce is that we want some behavior for the solvers that will be closer to what seems natural in the context of dynamics argumentation. So instead of reading at once the full set of updates in a text file, we would like the solver to wait for updates on the standard input. It seems closer, for instance, to what you have if you are in a debate. You don't know in advance the full set of arguments of your opponent and try to compute things with them. You just wait for these arguments to be stated by your opponent. So we want to implement this behavior for the solvers in the dynamic track this year. And for structured argumentation, I think that there's not much to say. Again, we focus for this first introduction of structured argumentation in ICCMA to the most classical semantics, so complete, preferred, and stable. And again, we take into account the 4 reasoning problems. And I recall that we consider the assumption version of the semantics. So for instance, for credulous acceptance, we don't look at the acceptance of arguments, but at the acceptance of assumption in some assumption-based extension. Regarding the scoring rules, so we will have 1 ranking for each subtrack, which means in total 12 rankings, 6 for the abstract argumentation track, static track, 3 for dynamic argumentation, and 3 for assumption-based argumentation. So if you want to have your solver ranked in a subtrack, it must participate to the full subtrack, meaning 4 problems or 2 problems in the case of ideal semantics. But there is no requirement at all to participate to all the subtrack in a track, or even to participate to all the tracks. So feel free to submit a solver for a specific semantics if you have a good algorithm for this semantics. Regarding the scoring rules, we chose to exclude from the subtrack a solver in case of any wrong result. So regarding some discussions previously today, of course, it means that approximate algorithm won't be able to participate to this competition. Maybe this could be a good idea for next competitions to implement this, but we chose here to focus on correct, complete algorithms. So this means that for each instance solved in the runtime limit, there will be 1 point. In case of timeout or non-parsable output, 0 point. And we will use the accumulated runtime over the correctly solved instance in order to break the ties. So to conclude with some information regarding what will happen in the next weeks and the next months. We expect to release all the formal details about the solver interface in this autumn, as well as the call for participation and the call for benchmarks. We will also provide with the solver interface some tools to help the solver developers, in particular for the dynamic track, since there is this new process of online solving the updates and instead of reading the whole set of updates on the input. So regarding the deadlines, we will hopefully follow this calendar, which is similar, I think, to ICCMA 2017. So in the beginning of 2021, in January, we expect the declarations of intent by the participants. A few weeks later, we will hopefully receive benchmark submissions from the community. And then in March, we want to have the solvers submitted in order to conduct some test phase in this moment, while the participants will finish their system descriptions before April. And then at the time of the next HKI, we will give the results. Regarding the next information about the competition and possibly updates to the calendar, you can have all the details really soon on this website, which will be updated in the next days. We will also use a mailing list of the ICCMA competition, and we will probably create a Twitter account really soon. It's not created yet, but we plan to use this mainstream social networks. So when it will be created, the information will be available on the website. So if you want to use Twitter, start with the website and you will have all the information at this moment. The members of the organization committee are available on this email address. So for any question, feel free to contact us. And of course, spread the word about the competition, because we welcome all participation from academics, but of course also of your students, if some of them are interested in this kind of challenge, or even of anyone in the community. So this is it. I thank you for your attention.